Well, thank you for joining me today. My name is Paul Teese, and in this edition of Trends and Directions from Jacobs, we're going to be exploring building safety in light of post-pandemic conditions. So, as you know, COVID-19 has disrupted our daily life and how we interact in our built environments. And as we're starting to take a look at returning to the workplace and other buildings, obviously people are thinking about health safety related to COVID-19, but what you may not be aware of are the hidden dangers that lurk inside buildings that have sat dormant for a while, such as water and air quality. And so there have been quite a few podcasts that of note that have come out that have discussed water quality, but today we're going to uniquely combine water quality, air quality, and sewer in buildings and discuss safety that building operators and owners should be mindful of. My guests today are Jesus Garcia Aleman, Jacobs Global Surface Water Technology Leader, and Charlie Funk, Jacobs Global Building Systems Solutions Director. So Charlie and Jesus, thank you both for joining me today. To start us off, Jesus, I'd like to ask you, can you describe for our viewers some of the health dangers of buildings that have sat dormant for a time?
Thank you, Paul. I wanted to first thank everybody for taking the time to listen, and I hope everybody's keeping safe. And I wanted to give a little bit of context about the issue. In a typical year, we'll see buildings that may sit dormant for a couple of days or weeks at a time over the holidays without experiencing necessarily any issues. Similarly, when we're at home and we choose to go on vacation, we may be inclined to turn off the power, dam, ventilation, or shut off the water to save cost and resources. And as a building manager, you may choose to do the same things. However, when these conditions persist over a long time, there can be some issues. And this is the crux of the problem. We're in an unprecedented time where we have schools or offices that are going to be shut down for 3 to 6 months, and hotels or convention centers that are going to be they're not going to be experiencing high traffic for 9 to 12 months. Mm-hmm. And for example, if you go and turn off the ventilation system that controls the building humidity during the summer, in the long term, you may experience mold or air quality issues. And Charlie is going to talk in depth about those issues. Then we can see on the water side, when the water is stagnant for a long time, that it's going to lead to issues. And I'm going to talk a little bit more about that. And now take into account that this is happening in hundreds of thousands of buildings around the world, that they're susceptible to the similar issues, and it's all happening at the same time.
Wow. So yeah, the scope and magnitude is just kind of unfathomable, I can imagine. So let's dive in a little bit about a building's water system. So how do you ensure the safety of a building's water system? I mean, from a building manager perspective, I assume there's more to it than just simply turning the water on and letting it flow for a time. Kind of walk us through some of the steps that you need to be mindful of. When I started looking into this problem and I read the research that you and Charlie had put on Jacobs.com. I was really fascinated that, because as a normal citizen, I didn't really think about, there's steps that probably you have to go through. You can't just go into a building and drink the water and use it. So you talk to us a little bit about how you safeguard a building's water system.
Thank you, Paul. Excellent question. I think the short answer is that as a building manager, they can choose to maintain the building systems, keep them in operation, and the monitoring in place during this time. And as I said, it could be a long time. But a lot of these demand-based systems, they may choose to just shut down and address the potential issues prior to reentry. And that has implications. The long answer in terms of drinking water quality is that once water leaves a water plant, it's highly dependent on the water flowing and being used, consumed, the chemicals that are in the water being replenished and monitored, right? This keeps the water fresh, prevents bacteria from growing, prevents materials that accumulate inside the pipe to being dissolved or suspended in the water. Over time, water stagnation and depletion of chemicals can lead to issues that some of us are familiar with, such as bacteria growing, which, people have heard of Legionella, disinfection by products, lead, copper, water discoloration when things come off of the pipe, taste another. And all these issues, I want to put a frame of reference for households that have a pool. You know that you have to maintain that pool. Water, the pump has to be on, the chlorine has to be added to avoid disgusting water. So now imagine that you cut off the power to the pump pool and you stop adding chemicals throughout the summer. Now I want you to imagine that that pool, it's in the shape of hundreds of feet of pipe inside a building that is complex, and some of this piping is hard to get to. Right? And now you have two choices. Either you're going to try to maintain that system running, which obviously there's a cost and there's a labor effort to do, or you just choose to deal with it with the mess later. And again, if you look at the analogy of the pool, we know that there's no free lunch here. It can be very difficult to deal with some of those issues later, but they have to be addressed. And that's going to mean, as Charlie's going to talk to us about, is you have to first go and assess if you have a problem. And depending on the complexity of your building, you're going to have to look at mitigation measures, which could be flushing, could be testing, and could involve disinfection, which, again, some people may hear the chlorine shocking. So all those things need to happen, or may need to happen, depending on the building. And it's a choice on when you do it.
Okay, and then, so, obviously, so unlike a pool, the water has to come from somewhere, right? It's not just like a body of water like you have in a pool, but you have to work with your local utility. And so, are there measures that building owners and managers need to be aware of when working with their local water utility, and who is responsible for what?
That's a great question. Water utilities, again, they're in charge of extracting the water that goes into the treatment plants and then conveying that water to the distribution system and to our houses and businesses. So the water, between the water plant and all the pipes in the street, those are maintained by the local water utility. And in cases where they see low flows or loss of residual, they're in charge of flushing and disinfecting that water main and maintaining the water quality. In the case of a building, the building manager will be responsible either on maintaining or restoring the water quality inside the building, which again, similar procedures will include flushing, disinfection, testing, monitoring. Now, when there's hundreds of buildings in a service water, think about a typical downtown or a business hub that, it's all office buildings, that you may see that at the same time, you're going to require a large amount of water to flush all those systems and a larger amount of sewer capacity to receive that flush water. And there has to be some coordination with the utility there. The other issue that I see here is local public health departments. They're starting to release some guidelines and advisories related to these issues. And lastly, there's coordination with there's service providers, which could be a company. Maybe you hire a contractor to do the flushing and disinfection. And then you have to send these samples to an accredited laboratory. And given that everybody's going to be on the same boat at the same time with you, this is going to take some time. So planning for your assessments, planning for your testing, I think it's going to be key here.
Yeah, wow, yeah, I can imagine that. And if you're not thinking ahead and trying to work with your local water utilities and getting on their calendars and that sort of thing, you run the risk of a real logjam, I imagine. So
yes, you cannot be thinking about opening on Monday and doing this on a Friday.
Yeah, you need to get ahead of it. So, Charlie, let me turn to you for a moment or so here. And let's talk about older buildings and newer buildings and some of the unique challenges there. So, what challenges might owners and managers of older buildings face when compared to newer facilities?
That's an interesting question in that, the building codes really establish what the minimum level of design is that we would do inside of buildings. And so, these codes have evolved and have changed over the years. And if you sort of look at some of the issues specifically, take hot potable water as an example.
Mm-hmm.
2012 International Plumbing Code, there were provisions in the code that these systems were designed so that they could be manually or automatically shut off when those systems were not being used. So, that was later changed. So now that provision is not in the code because we want to keep those systems operating. We want to keep those systems circulating. We want to keep those systems hot because the heat tends to drive out your sanitant out of the water. And so it's important really to sort of step back and understand, how was the building shut down? What are the systems that were in the building? And then just sort of understanding that design helps you sort of understand what the susceptibility of those systems are, as a result of the shutdown. So there are some more challenges that older buildings would face than potentially newer buildings.
Mm-hmm. All right, and then let's talk about air quality here and venting a building that's sat dormant. So what are some steps to properly vent and circulate fresh air in a building that has sat dormant? And, like before, I'm assuming it's not as easy as just opening the windows and allowing the place to air out. And, given the potential for things like chemicals from cleaners and treated furnishings, dry heat traps, and et cetera. So, what steps do we need to take here?
Well, natural ventilation is really a great way to bring fresh air into a building.
Mm-hmm.
The problem is you just can't do it all the time. Either the temperatures outside are too hot and it doesn't make it, where natural ventilation will necessarily work in all buildings, all types of the year. But when it does work, bringing natural ventilation in to supplement, your building systems is not a bad thing.
Mm-hmm.
But from the building side, you really sort of need to also step back and look at, well, how was the system designed? And is it designed to the latest codes relative to outside air and to indoor air quality? So that would be one thing, is just to make sure that the systems are providing those minimum levels according to the latest standards. ASHRAE 62.1 is the governing standard here in the United States. Another thing you can do is that, considering you pointed out that there's going to be additional cleaning and things like that that'll be going on in buildings. Mm-hmm. Flushing the building out with high outside air amounts, 2 hours before you occupy the building and 2 hours after people leave is also probably a good practice in order to again start the flush it at the beginning and the end of the day. P-traps, that's another thing that you may not think about, but when a building sits dormant and you're not using the water within bathrooms and other areas, those P-traps can dry out. Mm-hmm. And so when those P-traps dry out, these are the drain lines, then you can have potentially airflow that could come through the P-trap and into the building from the sewers. So there have been cases proven where viruses have actually spread through improperly designed and maintained sanitary sewers. So that's another thing. You just want to make sure that those traps are filled with water so that you don't have that potential flow of vapors through those lines.
Mm-hmm. And then, are there additional best practices to ensure workplace safety, considering the potential spread of the virus, particularly airborne viruses?
Yeah, that's a good question. And really, it's an evolving topic. There's a lot of science that's going on and discovery that's really going on to answer some of these questions. And a lot of these questions have been answered based on our knowledge of how similar viruses have reacted. But really, if you think about how it's believed the virus is spread, that it's thought that it's spread through respiratory droplets of people who are infected with the virus, many of which are asymptomatic. So droplets are emitted when we talk, when we sneeze, when we cough, when we sing even. And so the larger the droplets, the faster these droplets will fall and settle on the ground. Smaller droplets can in fact be carried in the airstream and in the air currents for hours, if not longer. And so that's one of the ways that the virus is spread from person to person. So if you think about it, your first real defense is really stopping the virus before it becomes airborne. And so that's really a mask. So, and the effectiveness of a mask, but that's your first level of defense. So if you can keep it out of the building, that's really good. I mean, the second thing is really, there's all different types of building types. And if we just talk about general commercial buildings as opposed to hospitals and other types, but if we just talk about general commercial buildings, then some of the recommendations I would say would be you would want to increase your filtration to at least a MERV level 13. This provides greater filtration for smaller particulate. Probably most buildings have MERV 8 filters in them, which is a lower grade of filtration. But when you change out those filters, it's going to increase your pressure drop. It may affect your fans. And so you need to make sure that you're recirculating the same amount of air that you were prior to the filter change out. And you do need to make sure that the filters fit tightly in the housing so that you don't bypass around the filters. So that's one thing. Another thing is demand controlled ventilation. Many buildings, in order to save energy, they were equipped with a feature that would allow the outside air to go down based on some measured parameter within the building. And so I think during this time, you want to disable that because we want to keep the outside air at higher levels during this particular time frame. Another thing this another very interesting topic is humidity control. Some of these studies have indicated that the virus, these similar viruses with moderate humidity levels can reduce the survival times. So if we can keep it at 50% humidity, then it can reduce the survival time based on these studies, and then humidity control may be a way that we can again reduce the spread of the virus. Another way that it may help is just if you think about how these droplets are formed, the drier the air is, then as these droplets fall, by having more humid air, then it can reduce the evaporation rate of those droplets. So that may allow those droplets to fall faster as opposed to part of it evaporating and then being suspended in the air, longer. Other things would be like UV lights in the, you can install UV lights in the unit, you can install them in the ductwork, you can install them even in the upper parts of the room that can also aid in eliminating inactivating the virus. So those are some different things that you could consider to increase your robustness of your systems.
Okay, and then let's go back to the question around time constraints. And hey, Sue, so, we talked about that a little bit about getting on the calendar of your local water utility, and so let's take a look at that, like go in a little deeper from a water and air perspective. And I'll start with Jesus, but I'm going to ask Charlie, I'm going to ask him the same question. So are there any specific time constraints that building operators need to be aware of for taking preventative measures? For instance, do some of the steps require weeks and weeks of effort, so they better get started now?
I think what I would recommend is, and I think Charlie is going to be recommending the same thing for the air systems, would be looking at it. You got to do an initial assessment on where you're at and understand whether you had a plan to maintain the systems functional, or did you just shut down everything and you need to recommission and restore performance to these units. That would be the first step. The second step would, you have to look at, okay, if you identify a problem, and let's just say, for example, it's water quality, it's gonna take some time to flush the system or even do shock chlorination. It's gonna take a time, but think about it. We're trying to get water or fresh water into first of all, you gotta replace all the existing water with new fresh water. And then you wanna be monitoring that water is maintaining water quality. And that may not be the case if something already started growing in the pipe. So you have to check that first. And again, samples, it may take you a week or so or more to just take the sample, get it back from the lab, confirm results. And if you have to hire someone to do more flushing or more specialized flushing, because take into account this is connected to an array of fixtures from faucets to taps to even dishwashers or fridges, right? You have to, for example, if you're putting water to a filter in a fridge, you have a disconnect, or an ice maker on the fridge, you have to disconnect to be able to get a sufficient velocity in that line, you will probably have to disconnect the ice maker and just flush it into a drain and to check that. So there's many steps, and again, it depends on the complexity of the building to do that. And that is frankly what's going to be linked to the amount of time that this may take.
And so that would be, first and foremost, you would have an assessment, and then that will help you determine your roadmap for how long how the time frame by which you have to prepare. Is that correct?
That's correct, because there's some buildings, because of the size or the simplicity of them, may not experience issues. And some may experience more complex issues.
Okay. And then Charlie, on the air side, you have anything to add to what Jesus was saying in terms of assessments and that sort of thing?
Probably the biggest difference is on the air side, as you're thinking about the air side, not only are you trying to get the building back up to where it was operating prior to the shutdown, but you may also want to make improvements to add additional additional items to the units to provide additional protection. And so when you do that, you do need to take time to evaluate what those options are, to plan, and then to allow time to have that work to be executed.
Okay. And then Charlie, this question's for you, is around taking all necessary steps and who to consult with. So who should building owners and operators consult with to ensure they are taking all necessary steps to ensure safe re-entry into their facilities?
There's considering all the different building types, there's probably not a single answer to that question. There are some checklists that are being created by a lot of the industry organizations and others that can assist building operators in going through and doing some assessments into helping that assessment. Depending on what you find in the assessment is when you may have to raise your hand and say, I need some additional help. So that's when you may want to bring in additional engineering support or to help if you find an issue, or if there's some upgrades that you're considering with your system that you may need additional engineering support to help with.
Okay, great. And in your opinion, how big are these concerns, and how concerned should building owners and operators be about this issue?
So, if I was to answer that question, again, I think part of the issue is really just thinking about returning the building to its operational state. Another part of that issue is improving the building performance. So when you take those two things into considerations and considering all the different building types, I think it's really important, to just you don't really know how big the issue is until you complete the assessment. But because these systems are so widespread and they're in all buildings, then this issue could be found in every building. You have the potential in every single building. So it is a widespread issue potentially that needs to be thoroughly investigated and assessed to make sure that there's not a bigger problem later.
Yeah. And then Jesus, any thoughts on that as well that you'd like to add?
I agree with Charlie, and I think I'm going to add one thing. How important it is to us here at Jacobs. We're currently, both of us, working with our real estate group we have over 404 offices globally, and we're working with that group to make sure that we take care of our colleagues, that there's a safe return to work. I also wanted to add that, as part of this outreach effort that we've been doing, we have prepared some informational brochure that also has links to other industry organizations that have put guidance documents and their own webcast and everything. So I invite everybody to look at this, but also consult with the other organizations. This is an issue that we're all on it. It's not just Jacob's issue or Jacob. It's something that we're going to learn as an industry from this. So I invite everybody, and I also want to thank everybody for their time on listening.
No, absolutely. And so the materials that you're referring to are on jacobs.com, where you can find, there's an article that explores this issue in more depth that's co-authored by Jesus and Charlie. It also has links to some guidelines and recommendations on what you can do to ensure a safe reentry into your building. So Jesus, Charlie, I want to thank you both for your time today. And I really appreciate your insights. So thank you.
Yeah, thank you, Paul.
Thank you, Paul. Thank you, Charlie. Thank you all.